right, that's the first sheet that you should have. So you see what it looks like. I'm going to switch over to my camera. All right. So there's some definitions up here at the top of the sheet that are things that we've already reviewed. Lines that intersect, they have an intersection point. And even though sometimes you don't see that they intersect, you need to understand that if you extend them, they may intersect at some point. Lines that will never cross, extended forever, they'll never cross, are called parallel lines. And lines that intersect to form a right angle are perpendicular. The symbol for parallel is just two parallel bars next to each other, almost like you're writing the number 11. So sometimes you might see something written like this. Segment AB is parallel to segment XY. The symbol for perpendicular is an upside down T. So you might see segment AB is perpendicular to segment XY. So on this first section down here, they want us to identify whether the lines appear to be parallel, and then if write L for lines that are intersecting. So P for parallel, L for intersecting. So when I look at number 1, I have two lines, and I have to think, if I extend those lines forever, will they ever cross? And in this case, the answer is no. So those lines would be parallel. For number 2, we can see that the lines do intersect. There's an intersection point. And so we need to write L for the fact that they intersect. Look at number 3. Do you think that those lines intersect or parallel on number 3? And you can put I for intersect and P for parallel will be fine. I for intersect, P for parallel. I for intersect, P for parallel. We're looking at number 3. Want to know if those lines intersect or are they parallel? Okay. Yes, even though they are not actually intersecting in the image that's here, if these lines are extended, they would cross. So they would intersect. They would intersect. How about 4? Number 4. Those lines look like they're going to be parallel or intersect. P for parallel, L for intersect. Do you think those lines are going to be parallel or are they going to intersect? Do you think those lines are parallel or are they going to intersect? Okay, yes, even though this one's drawn sort of short, if these were to extend forever, they are never going to intersect. That means they're parallel. The next section says write yes if the lines are perpendicular, write no if they are not perpendicular. So let's look at number 5. Perpendicular means they form a right angle, and so you have to sort of look at these. And I'm going to have to put my glasses on. And so when I look at this, I see that that is a right angle right there. So I would write, yes, those are perpendicular. For number 6, even though they're not intersecting yet, if I took and extended these, I would get something like that, and that is not a right angle. None of those are right angles. So these are not perpendicular. How about number 7? Do you think those are perpendicular or not perpendicular? Y for yes, they're perpendicular. N for no, they're not perpendicular. Y or N? Y or N are perpendicular. So we're looking to see if we see a right angle. Okay, correct. The answer is no. Those do not form a right angle. How about number 8? Do those look like they would form a right angle and be perpendicular? Number 8, those look like they would cross and form a right angle. Okay, yes, if I took this line and extend it, that's going to give me a right angle. And so, yes, these are perpendicular. For 9, 10, and 11, it wants us to look at this diagram and then answer these questions. The first question says, which line or lines are perpendicular to AB? So I'm going to draw AB. And there is only one line that is perpendicular to AB. The only one that would form a right angle would be this one here, which is line FE. And the way we denote a line is you put a line hat over the top of the letters. So you pick 2 points that are on the line, and the line hat is a little teeny tiny line that goes over the top of the letters with arrows on the end to indicate that that's a line. For number 10, they want to know, is FE perpendicular to DC? FE perpendicular to DC. What do you think? Is FE perpendicular to DC? FE and DC. Remember, we're looking to see, do they form a right angle? FE and DC. Do you think that they are perpendicular? Y for yes, N for no. Okay. Might be helpful if I draw this in a different color. There is FE, and there is DC. And be careful, those are not really forming. If I pull that off, that picture looks more like this. So they are not forming a right angle. The answer is no, they're not forming a right angle. They're not perpendicular. Then it asks, are there any parallel lines in this figure? Any parallel lines in that figure? Okay. All right. Now I'm going to throw this at you. Most of y'all are saying no. Why? Why are there no perpendicular lines? Ah, Miss Schramm. Yes. Very, very good. Yes. Miss Satterwhite, Mr. Nichols. Yes, they cross. They cross each other. And so if any lines intersect or cross each other, they can't be parallel. So the answer here is no. None of those lines can be parallel because they all intersect each other. Very good. Very good. All right. Then the next one that we're going to do. Okay, it should say basic angles and perimeter guided practice worksheet 1 at the top. That's what it should look like. So if you want to print that quick, it's actually 3 pages. All right, and I'm going to switch back to my camera. So this first problem, they're giving us the number of degrees in a particular angle. So they're telling us that DEG, this angle is 68.7 degrees. And they tell us that GEF, this angle is 46.3 degrees. They want to know what is the measure of angle DEF, which is this big angle. Well, in order to do that, we're going to use something, you don't need to really know the name of this, but it is called the angle addition postulate or rule, the angle addition rule. And so in order to calculate that, we're going to have to add those two angles together. So we can use our calculator. We take 68.7 and we add 46.3 and we get 115 degrees. Okay, do I need my light on? Let's see if that helps. Okay, so I punched that in my calculator. I got 115 degrees. All right, let's look at number 2. We're told that this angle is 29.1 degrees. And I'm assuming here it means this angle that's a question mark. And so we're only told one angle, that it's 29.1 degrees. Do we know another angle? Which angle is that? Okay, we're looking at our picture and we have this right angle mark right here, which means that the big angle is 90 degrees. So in order to find this angle, what kind of operation are we going to have to do? Subtract, all right? Correct. We're going to have to subtract. And so what we're going to have to do is take 90 degrees and subtract the angle that we know, 29.1 degrees. And when I punch that in my calculator, 90 minus 29.1, we should get 60.9 degrees. Because 60.9 and 29.1 would add up to give us 90 degrees. Same situation here. We want that missing angle. The missing angle right here. So tell me what the arithmetic problem would be to solve for this angle, the missing angle. What am I going to punch into my calculator? Okay, I'm asking what are we going to punch into the calculator to find this missing angle? I'm wanting to know, what do we punch in the calculator? Looking at what would I punch into the calculator? We know that the big angle is 90 degrees, and we know that 25.7 and the missing angle have to add up to 90 degrees. So in order to find the missing angle, I need to take 90 degrees and subtract the other angle, 25.7 degrees. So that's what I punch in the calculator. 90 minus 25.7, and I get 64.3 degrees, because 25.7 plus 64.3 degrees need to add up to 90 degrees. All right, let's look at number 4. This time we have a straight line, and we know that this angle is 73.1 degrees. I'm looking for the missing angle, the one that's missing. So what would I punch in the calculator this time? The pattern is kind of the same. We're doing the same thing. It's just that what we're going to subtract is going to be a little bit different. Okay, so I'm asking, what would I punch in the calculator? What would I actually punch into the calculator? What keys am I going to hit on the calculator? Okay, so you're correct. The big angle is 180 degrees. Part of the angle is 73.1. So our arithmetic would be 180 minus 73.1. And so when I punch that in the calculator, 180 minus 73.1, we get 106.9 degrees. Okay. Do this one and tell me what you get for the missing angle on number 5. Okay. No, Ms. Fossen, not 90. It depends on the big angle. On this problem up here, the big angle was 90. Here, the big angle was 90. But here, the big angle, the two angles together form this big angle that's 180. So you have to look at the picture, the diagram, to determine whether you're going to be subtracting something from 180 or something from 90. Okay, so I'm asking, what is the missing angle? What is this angle right here? HJL, this angle right here. Okay, that's what I'm asking you to calculate. What do you get for that missing angle? Okay, so you should be punching that in and telling me what you're getting as an answer. Okay, I'm looking for what that missing angle is. All right. Yes, the answer is 40.9. We do 180 and we subtract the 139.1, and that gives us 40.9 degrees. Okay. Now let's look at number 6. In number 6, we have two lines that cross, and we know that when we have two lines that cross, we get vertical angles across from each other that are exactly the same measure. They have the same degrees. And so angle 2 right here is the same as angle 4. angle 1 is the same as angle 3. Okay? And so they're telling us that angle 3 is 20.5 degrees, and they're telling us that angle 4 is 159.5 degrees. Well, first of all, we should look and see, because we should have, since those form straight lines, 20.5 plus 159.5 should add up to 180 degrees. They better, because they form a straight line. So looking at that diagram, what is the measure of angle 1? Let's start with angle 1. The measure of angle 1. Okay, we're looking for angle 1. So look at our diagram. Angle 1 is vertical. Okay. Angle 1 is vertical to angle 3. So angle 1 is 20.5 degrees. What is angle 2? Angle 2. We're looking for angle 2. We know that angle 4 is 159.5. We're looking for angle 2. Angle 2. Don't have to do any calculations here. Angle 2. Okay. Yes. Angle 2 is vertical to angle 4, and so angle 2 is 159.5 degrees. Okay. There was no calculating there. We just have sets of vertical angles. All right. On the back page. On the back, we're told that angle 1 is 126.4, and that angle 2 is 53.6. And 53.6 and 126.4 do add up to 180 degrees, which they better, because they form a straight line. So you tell me, what is angle 3 and what is angle 4? Tell me what angle 3 is and what angle 4. Angle 3 and angle 4. Tell me what those angles are. And on your keyboard, next to the M and next to the question mark, your shift key will give you greater than, less than, but you can use the less than symbol as an angle mark. So again, I'm asking, what is the measure of angle 3 and what is the measure of angle 4? The measure of angle 3 and the measure of angle 4. So angle 2 and angle 4 are vertical. So if angle 2 is 53.6, then angle 4 is 53.6. And if angle 1 is 126.4, it's vertical to angle 3, and so angle 3 is 126.4. Look at number 8. All it's asking for here is, what is the relationship with this angle and this angle? Are they complementary? Are they supplementary? Are they vertical? Are they adjacent? Okay, let's be very careful. The word complementary and the word supplementary. Complementary means the two angles have to add up to 90 degrees. Well, that right there is already over 90 degrees just by itself. Supplementary means the two angles add up to 180 degrees. If I took this angle and I added this angle to it, it would come down like this. This would be the first angle, angle S, and we put next to it angle D. We put that up here. It would be this. Those don't add up to 180 degrees. These two angles are too big to add up to 90, and they're too big to add up to 180. These angles are vertical. I used to tell my students when I taught geometry, think of vertical angles as two V's with the same vertex. Here's a V and here's a V, and they have the same vertex point. Two angles, two V's with the same vertex. Okay? They cannot be adjacent because they're not next to each other. They're across from each other. Okay? Look at number 9. We want to know, are these complementary, supplementary, vertical, or adjacent? Well, one of those choices you can immediately drop out, because in order to be a vertical angle, you have to have two V's across from each other. This angle and this angle aren't across from each other like these were. So can't be vertical. Complementary, they have to both add up. This angle plus this angle have to put together to form a right angle, 90 degrees. Supplementary, they have to be put together to form 180 degrees. Well, that's obviously not supplementary. And we can see that in order to be 90 degrees, this side would have to be up here some kind of way. So it can't be supplementary. These angles are adjacent. They're next to each other. They have the same vertex, and they share a side, and they don't overlap. All right, let's look at number 10. Number 10 wants us to find the perimeter of this shape. Remember that perimeter means we add up the sides. So the perimeter would be this side, 4 centimeters, plus this side, which is 5 centimeters, plus this side, which is 6 centimeters, and we get 15 centimeters. 15 centimeters. You have to be careful with perimeter, because perimeter is a specific dimension, and we have to put the units on there. You can't just say 15 because we don't know 15 what? 15 miles, 15 inches. You have to put the units on there. Let's look at number 11. Again, we're finding the perimeter. Perimeter means add the sides. So we have 4 kilometers plus 3 kilometers plus 4 kilometers plus 2 kilometers. And so when we add 4 plus 3 plus 4 plus 2, that's 8, and 2 is 10. We get 13 kilometers. 13 kilometers. Okay. All right, let's look at number 12. They want to know, what is this angle right here? Okay, and that is because these are vertical angles. And so, yes, this angle is 68 degrees. Look at number 13. They want to know, what is the complement of 39 and 2/3? Uh-oh, fractions. Not going to get away from them. We're going to continue to have them all the time. So we need to know, what is the complement? Complement means they add to 90 degrees. Complement means add to 90 degrees. So if I want to know what is the complement of this angle, I take 90 degrees and I subtract that angle, 39 and 2/3. Okay? We can use our calculator. I strongly suggest that you get one of these calculators so that you're familiar with using it when you go to take the test. So I'm going to punch in 90 minus, and this is a mixed number. And if you'll remember, there's a mixed number key right here on the calculator that says UND. U as units and N numerator, D denominator. And it's in green, so to activate it, I have to hit the second button. So I punched in 90. I'm going to hit second so that it activates this green button when I hit that. And now I have the mixed number format, so I can punch in 39, arrow over to the numerator, which is 2, denominator is 3, arrow out, and hit enter, and I get 151 over 3. But I don't want that as an improper fraction. I want it as a mixed number. So if you remember, there is a key here that is fraction to mixed number. That's ND, arrows and unit ND. So that's our conversion button. So I hit second and that button, and then hit enter, and I get 50 1/3. 50 1/3. B is asking for the supplement of 105 1/4 degrees. Supplementary angles have to add to 180 degrees. So the arithmetic I'm going to do here is 180 minus that angle, 105 1/4. So in my calculator, I punch in 180 minus, and I have a mixed number, so I hit second fraction, and it activates the mixed number format. I put in 105, hit my arrow and move over. I have 1/4. I hit enter, and I get 299 over 4. But I cannot leave that as an answer. And so to change that into a mixed number, I hit second and the convert button, which is this X10N or whatever that says. I hit that button and then hit enter, and I get 74 3/4 degrees. If you don't have one of these kind of calculators, then what you're going to have to do, and in most cases, especially on the GED, they're not going to give you this answer in decimal format. It's going to be in fraction format. And so you're going to have to either convert this to a decimal, and then when you get done, convert it back to a fraction, which is going to take you forever. In some cases, the decimal would be okay, but then you've got to convert back to a fraction. I don't want to have to do that. All right, here it's asking for the complement again. So complement means they add to 90. So I take 90 degrees and I subtract the angle, which is 3 3/10. And so in my calculator, I punch in 90 minus mixed number is the fraction, second fraction, 3, arrow over to the numerator, arrow down to the denominator, arrow out of the mixed number, hit enter, and I get 867 over 10. And this is going to need to be in fraction format. So in order to convert, I hit second and this key, enter, and I get 86 and 7/10 degrees. The typical rule is if the problem is given to you in fractions, you give a fractional answer. If the problem is given to you in decimals, you give a decimal answer. All right, we have a few more. Here they want us to find the perimeter, but they have not given us all of the sides. So we have to use what we know. So this side is the same length as this side. So this would be 15 over here. Now, this side looks like it would be 9, but it's not part of the outside, so we don't include that side. You have to be careful with some of these shapes. Sometimes they'll throw in a side that's not needed. Perimeter means go around the outside. So we know this one, this one, this one, this one, but we don't know this one. It's the same as this side, so that is 5. So now our perimeter is 5 plus 15. And I'm doing the same thing that Math with Mr. J does. Mark off the side so I know I've included it. And so when I add 1, 2, 3, 4, 5 sides together, 5 plus 15 plus 9 plus 15 plus 5, we get 49. No units are given, so we don't need any units in the answer. Okay. The last page, number 15. I want you to tell me what the missing angle is. And we're going to be doing tons of this. So you will get lots of extra practice, lots of it. Look at this image and see if you can determine what the missing angle would be. What the missing angle would be. The missing angle. Look at what you know, because you actually know 2 things in that image. There are 2 things we know, 1 thing we don't know. 2 things that we know and 1 thing we don't know. So we should be able to use that to help us find the missing angle. Okay. We know that this big angle is 90 degrees. So the big angle is 90. It is made up of 2 smaller angles. One of those angles is 63. We need to know what's the rest. Well, the arithmetic is 90 minus 63, and you're correct. We get 27 degrees. Do number 16. See what you get for number 16. Number 16. Okay. So the big angle is 180 degrees. This much of it's 24. We need to know how much the rest is. So the arithmetic is 180 minus 24. We get 156 degrees. Okay. Look at number 17, finding the perimeter. So we need to know the lengths of the sides. So there was one similar to this that Math with Mr. J had. We know this side, we know this side, we know this side, and we know this side. We do not know, off just because it's not drawn on the sheet or on the image, not labeled, this side is missing and this side is missing. So what we have to do is use the information that we know. From here to here is 1.5 meters. So this much is 1.5. From here to here is 4.5. So he was talking about taking that segment, that piece, and think of taking this side and moving it all the way down to here, and taking this side and moving it all the way down to here. And so 1.5 and 4.5 would give us 4, 5, 6 meters. Okay, 6 meters. Then the missing side here, well, this whole side is 5, so from here up to here would be 5. This much is 1.2. So if we take 5 and subtract 1.2, this much is 1.2 down to here. The rest of it then has to be how much? 3.8. That's correct. 3.8. Now we know all the sides. So now we can say that the perimeter is 1.5 plus 1.2 plus 4.5 plus 3.8 plus 6 plus 5. And so when we add all of that together, did y'all get it? 22, is that what y'all are getting? 0.5 plus 1.2 plus 4.5 plus 3.8 plus 6 plus 5 is 22. So the perimeter is 22 meters. 22 meters. All right, let's look at number 18. The only missing side is this one right here. Well, let me ask you this. How long is it from here up to here? How long is that? Okay, I'm asking how far is it to go from here up to here? Okay, yes, it's the same as this side over here. Think of a house. So this wall is 12 meters. So from here all the way down to here is also 12 meters. Well, we know this much is 3 meters, and we know this much is 3 meters. So from here to here is 3 meters, and from here to here is 3 meters. I need this piece here. Well, all of it is 12. So if we take 12 and subtract 3 and 3, we get, what is the length of this missing piece? Okay. Yes, 6 meters, because from here to here is 3, from here to here has to be 6, from here to here is 3, because they're matching these sides, and so from here to here is 12. That piece has to be 6. Now we know all the sides, so our perimeter is 12 plus 3 plus 7 plus 6 plus 10 plus 3 plus 15 plus 12, and we've gone all the way around. So marking off those sides helps you make sure you get all of the sides listed. Okay, then we add all this up, and what did y'all get? Y'all got 68. Is that what y'all are getting? 68? That sounds correct. $68 meters. What is a real world application of these drawings? What is a real world application of these drawings? Real world application of these drawings. Okay, good. Yes, all those answers are correct. The typical answer is called floor plan. So that could be a room, it could be a building, it could be a blueprint of a building, it could be a house, it could be a shed, it could be fencing around a yard, or fencing or a gate around maybe some sort of, maybe a hog pen or something. And so these have real world application to them.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.